Script title. Behind the scenes, how communication satellites are built and launched. Opening scene. Dramatic music plays softly in the background. The screen fades in from black to show a satellite floating silently in space, with the Earth slowly spinning below. As the camera zooms in, a question appears on the screen. How do we build and launch a satellite that can connect the entire world? Narrator. Thought-provoking tone? Think about it. Every call you make, every television broadcast you watch, and the very internet connection that links you to this video might be traveling through a satellite, orbiting tens of thousands of kilometers above us. But have you ever wondered how these satellites are made? Why they're built with such precision? And how they reach their destination in space? Cut 2. Quick clips showing a busy factory floor with engineers working on different satellite components. Tools buzz, sparks fly, and screens light up with 3D designs. The screen fades to the narrator standing in a workshop filled with satellite parts and technical diagrams. Narrator. Today, we'll dive deep into one of the most complex industries in the world, satellite communications. From the first spark of design, to assembly, testing, launch, and ultimately reaching their place in orbit, this is how communication satellites are created and deployed. Narrator. Engaging tone. By the end of this video, you'll know the secrets behind these marvels of engineering and understand the enormous efforts that go into ensuring they stay operational in the harsh environment of space. Segment 1. Why do we need satellites? Narrator. Contemplative tone. So why do we need satellites? It's simple. To connect, observe, and navigate. Most of the satellites we rely on can be grouped into 3 main categories: observation, navigation, and communication. Cut 2. Footage of Earth taken from space, showing clouds swirling and continents visible. Narrator. Observation satellites scan the Earth, helping us predict the weather, monitor natural disasters, and even map our planet in incredible detail. Navigation satellites, like GPS and GLONASS, help us find our way whether we're in a car or crossing the ocean. Cut 2. An animated globe showing satellite paths in geostationary orbit, with some satellites labeled as communication and positioned high above the Earth. Narrator. And then there are communication satellites, the most complex and massive of them all. Positioned nearly 36,000 kilometers from Earth, these satellites relay data, television broadcasts, phone calls, and more, connecting every corner of the world. Segment 2. From carbon fibers to spacecraft. Building a satellite. Narrator. Energetic tone. But how do we actually build these technological masterpieces? Well, it all starts with a material that might surprise you: carbon fiber. This lightweight yet strong material forms the backbone of many satellite structures. Cut 2. Engineers working with carbon fiber sheets, layering them carefully over a mold before they are hardened into shape. Narrator. Sheets of carbon fiber are cut, shaped, and hardened to form the primary structure of a satellite. The goal? To keep the satellite both durable and incredibly light. Why? Because every kilogram that a rocket has to lift into space costs fuel, and that means higher costs. Cut 2. A 3D model of a satellite, with the service module and payload highlighted. Narrator. The satellite is divided into 2 main parts: the service module and the payload module. The service module is like the body; it houses engines, batteries, and solar panels. The payload module, on the other hand, is the brawn. It carries the antennas and transponders that handle communication. Cut 2. Engineers assembling microchips and testing them. Close-up shots showed tiny wires being connected with precision tools. Narrator. Just like a smartphone or laptop, satellites rely on microchips to function. But unlike consumer electronics, satellite components are built to withstand the extreme conditions of space: intense cold, scorching heat, and constant radiation. Segment 3. Testing in extreme conditions. Narrator. Serious tone. Once assembled, every satellite undergoes rigorous testing. Because, unlike your smartphone, if something breaks in space, there's no sending it back for repairs. Cut 2. A thermal vacuum chamber, with a satellite being lowered into it. Narrator. Take the thermal vacuum chamber, for example. This giant machine recreates the conditions of space, with temperatures ranging from -150 degrees Celsius to a blistering 150 degrees above. The satellite must endure this extreme environment without any loss of function. Cut 2. Footage of a satellite shaking violently on a vibration stand. Narrator. Next, the satellite is shaken violently. This simulates the force it will experience during launch. After that, it's exposed to deafening sounds in an acoustic chamber, mimicking the roar of a rocket engine. If the satellite passes all these tests, it's ready for its biggest journey yet. Segment 4. Transport and final assembly at the spaceport. Narrator. Excited tone. Once the satellite is cleared, it's transported to the spaceport in a specially designed container to protect it from vibrations and shocks. Upon arrival, the real work begins, attaching it to its launch vehicle. Cut 2. A time-lapse of a rocket being assembled in a clean room, with the satellite being lowered into place on the upper stage. Narrator. The satellite is gently mated to the upper stage of the rocket, a process that can take days, sometimes weeks, to complete. This stage, also known as the booster, is designed to give the satellite its final push into orbit. Cut 2. Engineers inspecting the satellite's connection to the rocket and sealing it inside the rocket's nose cone. Narrator. Once securely fastened, the entire assembly is sealed inside the rocket's nose cone. This protective shell will shield the satellite from aerodynamic forces as it climbs through the atmosphere. Segment 5. The launch and on-orbit operations. Narrator. Anticipatory tone. Launch day arrives. The rocket is transported to the launch pad and raised to a vertical position. Fuel is loaded, systems are checked, and the countdown begins. As the engines ignite, millions of pounds of thrust lift the rocket off the pad, carrying the satellite to its new home. Cut 2. Footage of a rocket launch, with fiery plumes erupting from the base and the rocket soaring into the sky. Narrator. But reaching orbit is only the beginning. Once the rocket's main stages burn out, the upper stage takes over, firing its engines multiple times to place the satellite into its precise orbit, 35,786 kilometers above Earth, to be exact. This maneuver can take hours, and only when it's complete can the satellite begin its mission. Cut 2. Satellite operators at a mission control center, monitoring screens filled with data and live feeds from the satellite. Narrator. Even in orbit, the satellite isn't just left on its own. Ground teams constantly monitor its position and make small adjustments to keep it on course. Tiny thrusters fired to counteract the gravitational pull of the moon, solar wind, and other forces. Closing scene. The camera zooms out from a satellite in geostationary orbit, looking down on a brightly illuminated Earth. Narrator. Inspirational tone. It's a testament to human ingenuity that these satellites, built with such precision and care, can function flawlessly in such a harsh environment, bringing us all a little closer together, no matter where we are. Narrator. With that said, thanks for watching, and until next time, keep looking up at the stars. End screen with outro music and suggested video thumbnails appearing. Did you know that building a communication satellite takes over 200,000 carefully assembled parts and countless hours of testing, all to ensure it can survive the harshest conditions in space? In today's video, we're uncovering the step-by-step process of creating these incredible machines, from the initial design to the powerful rocket launch that sends them into orbit. We'll break down how satellites operate thousands of kilometers above us, explore the intricate launch procedures, and share how these massive investments in technology can yield even bigger returns. So stick around till the end to learn how launching a satellite isn't just about reaching space, it's about coming out stronger and richer. Welcome to British Story. If you enjoy learning about science and technology, make sure to hit that subscribe button and join our community.